Hi everyone, today we are going to talk about how to determine RPM. RPM stands for revolution per minute. Our purpose is to decide how fast I should set the spindle to spin for my cutting operation. Let's say we have a drilling machine here. What will happen if we set the spindle to spin too fast? In this case, our cutting behavior will be called sliding. What does sliding mean? That means you are moving too fast, and you could cause overheating because you are creating too much chips at a short amount of time. It doesn't have enough time to get all those heat out. It will cause overheating and destroy the workpiece, and you might just lose the precision you need. And what would happen if you spin too slow? The cutting behavior would be called plowing. Plowing means you are not cutting with enough speed, so you are kind of just dragging the material along with your cutting route. So either you would destroy the material or you cause a rough surface at your final finished workpiece. So either spin too fast or spinning too slow will cause problems. So we need to know what is the ideal spinning speed we should set for our spindle. So let's say on the left side we have our drill machine. There are several factors we should know to decide how fast we should set our spindle. The first thing we should know about is when the cutting tool touches the material, how fast the cutting tool can handle a specific kind of material. This is something called cutting speed, and we usually look it up from the manufacturer chart. And to determine the cutting speed, we first need to know what kind of cutting operation we are doing right now. For example, are you drilling, reaming, or you are turning, or milling? Each type of cutting operation will apply different level of stress to the workpiece material, so it would affect the cutting speed we need to use. Second, we also need to know the cutting tool material. What kind of material we use to make up our cutting tool? Usually we use high-speed steel. If you want to go a harder material, you can also use carbide, which usually offers a higher cutting speed to use. So these two factors are coming from the cutting tool. And the third factor we should know is the workpiece material we are gonna cut. For example, aluminum, brass, mild steel. Each material can stand different level of cutting stress. So with these three factors, cutting operation, cutting tool material, and workpiece material, we can then decide the cutting speed, or called service feet per minute, SFPM. And keep in mind, this one is not how fast we can set our spindle, because spindle needs to know how many revolutions to do per minute. Right now, this is cutting speed, it's a service feet per minute. It represents how much the cutting tool and the material can hold each other, without causing problems either sliding or plowing. So in order to know how fast we should set our spindle to spin, we also need to know the cutting diameter. The cutting diameter in this drilling machine is diameter of our cutting tool. But if we are talking about the turning on a lathe, then the cutting diameter will be the workpiece itself. And with this one, we can determine our final number, RPM, revolution per minute, which is how fast we should set our spindle to spin. But let's go back. Why do we need the cutting diameter to know the final RPM number? Because right now here, the cutting speed only means how fast the material and the tool should contact each other. But right now we need to know how many revolutions per minute. So we need to know the diameter. For example, if you have a smaller circle and a bigger circle, if you run around a smaller circle for circumference, if you want to run the same distance on a big circle, you don't need to run the full circumference. You only need to run part of it. So that means in a smaller circle you need one revolution. But for the bigger circle, you only need part of the revolution. So that causes the difference revolution per minute we need, even though the distance is the same. And the distance here is similar like the cutting speed. With this in mind, we take the cutting diameter into consideration. With cutting diameter and the cutting speed, we can know the RPM we should set for our spindle to spin. So next, let's focus on how to calculate RPM then. So our RPM will be equal to cutting speed in feet, and we will look up the manufacturer's chart to know this by considering these three factors we talked about. And then we will convert the feet into inches by times 12. Then we divided it by diameter. Either it's the cutting tool's diameter or the workpiece diameter, depending on your cutting operation. And from diameter, we want to know the circumference, so we times the diameter with pi number. And to simplify this, we usually use the number 3.82, then times cutting speed divided by diameter. So let's do some example. So here is a cutting speed chart from this little machine shop. And we can see first we need to decide what's our cutting operation. Either turning, milling, drilling, or reaming. Let's look at the turning first. So here, the next step we can decide is our cutting tool material. You can either use the high-speed steel or carbide. Let's say right now we are using the high-speed steel for our cutting tool material. Then next, the third factor we should decide is the workpiece material. And then we can know what is the cutting speed we should use. Let's take another example. Let's see we are doing the drilling and reaming. And then you can notice here it does not specify the cutting tool material. So by default, if you see nothing here, it means it is using the high-speed steel. So we can move on here. The workpiece material, let's say we want to use this carbon steels. And this time we are doing the drilling operation with the default high-speed steel cutting tool material. Then our cutting speed will be 100 to 120. Let's do the 100 here then. Then let's go back to our formula. So 100 is our cutting speed in feet. Then we need to know the diameter. Right now we are focusing on the drilling operation. So the diameter is the cutting tool's diameter. So here is a side, one of the cutting tool for the drill. The cutting tool material is high-speed steel. And let's look up the diameter. You can see here, the cutting diameter is 0.5 inch. Perfect. Let's go back to our formula. So we also know the diameter here, 0.5. Then let's do a calculation. So cutting speed is 100. And then let's divide it by diameter, 0.5. And then times our 3.82. And this is the final speed we should use. 764 is our RPM we should set for our drilling operation. And one thing to notice is this is the ideal RPM we want to set. But always consider the limit of your drilling machine. If your drilling machine limit is below the RPM you want to set, then you need to respect what your machine is capable of. So here, let's do a quick summary. So first, you need to look up the cutting speed. Cutting speed means how much the cutting tool and the material can stand each other. It's decided by three factors: cutting operation, cutting tool material, and the workpiece material. And then you need to know the diameter to decide how many revolutions is needed for the same cutting speed. So diameter is decided by the cutting diameter, either by the tool cutting diameter, such as drilling, or by the workpiece diameter, such as turning on a lathe. And then this is all just some concept. Eventually, it will just become a constant number you need to memorize, 3.82. Then you can get the RPM, and then check it with your machine, whether your machine can handle the ideal RPM you want to set. So hopefully this video helped you understand how we calculate RPM and what it stands for. If you like the video, please like the video, share, and subscribe. Thank you.